Is Rosario Valotta, and as you can guess from the talk's title, we're gonna discuss about some issues, some security issues about browser interface security, browser user interface security. More in detail, we're gonna see how an attacker can use some security-related problems to browser security notification in order to compromise victim security and also get code execution with just a little bit of social engineering. Before starting with technical details, just a few words to better introduce myself. I come from Rome, Italy, where I work as a project manager in mobile telecommunication company. So that is my daily job, but in my spare time, which is mostly night time, I practice web security. I'm active in this field since 2007. I released a bunch of advisories, proof of concept, and new attack techniques. Maybe some of you heard about some of my previous works, for instance, cookie jacking, which was presented at Hack in the Box a couple of years ago, or my Andrea Domfadzer, presented at DeepSec conference a few months ago. But I don't want to bug with all the list of my previous work. If you're interested, you can check them out on my website. Let's start our discussion talking about social engineered malware. Malware spread without any doubt is one of the most compelling problems that web security industry has to face nowadays. Malware spread is increasing year over year, and according to some reports provided by Kaspersky Labs, in 2012, more than 200,000 new malware samples were spotted every new day. And this led to more than 1.5 billion attacks originated by malware over the web. But the most interesting thing is that most of these attacks were originated by user-initiated download. So we are not actually talking about zero-day exploits, drive-by download attacks, and so on. We are talking about more than 1 billion users who proactively downloaded some executables on their computers, double-clicked on them, and get infected. So it's quite obvious that when talking about user security, you cannot rely on user awareness, on a user consciousness, because the average user is completely unaware of what he's doing while surfing the internet. Users need guidance, they need protections from malicious websites, and we can deliver these things by providing a reliable browser security mechanism. That's why in the latest years, browser vendors invested a lot of money and effort into building some reliable security mechanisms, ranging from memory protections technologies, for instance, ASLR, DepGS, and so on, to protection against web attacks, for instance, XSS filters, anti-framing technologies, and so on, from malware and phishing protection, for instance, Smart Screen Filter by Microsoft or Safe Browsing by Google. And last but not least, a lot of effort has been posed into building trusted and recognizable user interfaces in order to help users in making aware choices while surfing the internet. And when talking about trusted and recognizable user interfaces, we are talking about Chrome. For the few of you that are wondering what is Chrome, Chrome is not, I'm not talking about Chrome as Google browser. I'm talking about Chrome, about all the sets of user controls, pop-up menus, notification bars, and so on, that surround the web content in the browser, providing an interface between the user and the browser. So to say it with a couple of slides, this is Chrome, and this is content, right? It's not always easy to distinguish Chrome from content. For instance, this is a screenshot taken from an attack dubbed the picture-in-picture attack. At the first glance, in this attack, it's not easy to distinguish the outer Chrome, which is the authentic one, from the inner Chrome, which is just an image, just a JPEG. Of course, this is a phishing attempt in which the attacker is tricking his victim into inputting his PayPal credential into text form by eventually delivering this credential to the owner of paypal.login.com, whatever it is. But picture-in-picture attack has not been the only attack targeting browser user interfaces in the latest years. Another quite dangerous attack is a URL obfuscation attack. This attack exploits a flow in browser that are not able to render reliably the URL required by the user. Generally speaking, a URL can also embed some credential. So the general format is HTTP column username column password at domain. Okay, so when a user is tricked into click a URL like this, there is basically a gap between the user perception of the URL and the browser parsing of the URL, because the user is led to believe he's going to visit bankofamerica.com, but actually browser, after parsing, resolves navigation to that IP. And only the latest version of browser patched this vulnerability by raising a warning like this, asking, are you sure you want to visit that IP? Or maybe you are a victim of a phishing attempt. Of course, different vendors patched this vulnerability in different ways. Internet Explorer took a drastic approach by completely disabling URL resolution for URL with embedded credentials. Google Chrome took another approach. It renders the web page and strips credential from the location bar, so giving the user a clearer perception of the domain he is visiting. Another quite interesting attack is the download dialog spoofing attack. The attack was demoed by Michael Zaleski from Google. As the name itself suggests, it is a spoofing attack against download dialog notification. The attack scenario is more or less the following. You visit the attacker web page. The attacker immediately spawns a new navigation window towards a BNN website, adobe.com in this case, right? After doing that, the attacker website redirects navigation towards a URL served with content disposition attachment header. That means start download some file. The side effect of this is that the notification bar about the download, this one, appears in the context of the BNN website. So the user is led to believe this is a trusted download coming from adobe.com. Okay? And this attack is quite dangerous because it's still working in Internet Explorer 9, Chrome 25, and Firefox. It has been patched in Internet Explorer 10. So from this last couple of examples, it's quite clear that browser security notifications play a very important role in order to guarantee user security. Because they are a crucial part of the browser trust model. They are very helpful in notifying user before making important choices, and they provide a communication medium between the user and the browser. So they need to be trusted and easily recognizable. Nowadays, two types of browser notification exist. Modal notification and modeless notification. Modal notification are the classic dialogues that pop up in the middle of the screen asking you to make one decision, okay? And you can answer, okay, okay, cancel, accept, deny, yes, no, whatever. So they are characterized by a strong visual contrast in order to grab your attention, and they are workflow blocking. So this means that you first have to dismiss the pop-up dialog by answering the question, and then you can continue your navigation. They can be triggered by the OS or by the browser. In both cases, they share a common problem. It's called a default answer problem. In order to dismiss this dialog as quickly as possible, the average user, is led to click on the default answer without paying attention to the message delivered on the dialog. And this is bad for user experience, but also for security. That's why in the latest years, some other kind of notification appeared, modelless notification. Modelless notification are rendered by notification bars like this, appearing on the top or on the bottom of your browser, depending on the browser and depending on the notification type. They are designed in order to inform user, provide information without interrupting navigation. So they stay in the context of the navigation window. They are part of Chrome, so of the browser process, not part of document object model. That means that you cannot interact with that using JavaScript. What they're used for? They use it for file downloading notification, plugins activation or ActiveX activation, and also for HTML5 APIs notification. For instance, all those sites using some privileged APIs, for instance, geolocation API, file system API, full screen API, they need to ask for your approval before using that functionality. And this approbation is required using these notifications. In the latest years, we assisted to a progressive shift from modal to modelless notification in all mainstream browsers. you can see that Internet Explorer, Firefox, and Chrome, they adopt model-less notification in every use case, except extensions or advanced installation, which is quite sensitive, and they need to be clearly notified to the user using model dialog. Safari, on the other side, keeps staying on model notifications only. So model-less notifications are smart, they are not annoying, but they suffer from some problems. First of all, they are displayed even if the window is on the background. Second, some keyboard shortcuts are enabled for notification bar, for interaction with the notification bar. Notification bars can be navigated using the tab key on your keyboard, and notification bars are bound to the navigation window. Let's go through each of them. First of all, notifications in background windows. Imagine a scenario like the following. You visit the attacker website. The attacker website immediately spawns a new navigation window, a pop-up dialog, a pop-up window, okay? The pop-up is immediately put on the background, so it actually becomes a pop-under. Now, just a little parenthesis about pop-under. There have been a struggle between, let's call them hackers on one side and browser vendors on the other side for the control over pop-unders, because they are very annoying on one side, but very lucrative on the other side. And so every time a new browser version comes out, some APIs, some methods to control pop-unders are dismissed. But hackers find new way to control pop-unders. So if you, for instance, browse over GitHub, you can find some implementations, for instance, JS pop-under, that enables pop-unders in a cross-browser environment. So at this moment, we are able to open a pop-under, okay, in the background. On Windows 7 and on Windows 8, the pop-under is merely unnoticed. Why? Because the several windows of the same browser session are tabbed very closely in the application taskbar. So especially if you have many windows open, it is merely impossible to distinguish if a pop-under has been triggered or not. The pop-under starts a download. After the download is finished, a notification bar is triggered, but it is hidden from the user view. And more, the pop-under doesn't blink to give evidence of a pending notification for the user. So at this moment, we have a file downloaded over our machine, and no information is provided. This can be very dangerous. I will show you in a few minutes. Second problem, keyboard shortcuts. They are available in order to interact with the notification bars. For instance, Internet Explorer allows this for interaction with download notifications. You can press Alt and then R, or Alt and then S, or Alt and then O in order to run, save, or open your file, okay? Internet Explorer and Firefox allow this for HTML5 API notifications. This means that you can press Alt and O or Alt and A in order to grant the geolocation privilege to that website. Of course, in order for these shortcuts to work, the navigation window needs to be on focus. Third problem, using tab in notification bar. Some browsers allow using tab to switch among the different buttons, different options provided in notification bar. For instance, Internet Explorer allows this for file download notification. This means that you can press tab multiple times in order to switch between run, save, cancel, and close. Google Chrome is a little more secure because it skips the file opening button, allowing you to switch between show downloads and close. Okay, just a side note, notification bar is part of Chrome, so you cannot simulate navigation using JavaScript events, okay? You have actually to press your key on your keyboard. Last problem, notification bars are bound to the navigation window. This means that being part of Chrome, they can be moved along the screen, along with the navigation window, resized with the navigation window, and closed together with the navigation window. This may seem obvious, but it led to some minor security problem. I will show you with talking about the second type of attack. I will demo. So these four problems are basically the building blocks that I've used in order to design the two attacks I will show you now. The first attack works on Internet Explorer 9 and 10, both on Windows 7 than on Windows 8. The attack scenario is more or less the one depicted before. So you visit the attacker website spawns a pop-under, the pop-under starts download of a file. All of this is unnoticed. So after notification is ready, the pop-under window is still on the background, so hidden from the user view, but it has the focus. It is the Windows on focus. So this means that every keyboard input that you type on your keyboard will be directed to the Windows on focus, so to the pop-under, and not to the foreground window. So if you're able to trick your victim to type some sensitive keys, for instance, Tab and then R, you can get code execution without any notification or without any user confirmation. Let's see how it works. This is the foreground window. This is the background window. Okay? Look at the Chrome color. This is gray. This is blue. This is not on focus. This is the window on focus. The download is ready. So every keyboard input will be directed to the window on focus, so the pop-under. The shortcuts are available for interaction. So you can press Tab to move the focus on the Run button. And then you can press R or equivalent key. It changes according to the OS language. For instance, in Italian is E, to execute program. Okay? Let's see this in action. Let's move to Windows 8. The proof of concept I thought about is a typing test. Okay, it's one of the proof of concept that you can design. You can find a lot of typing tests for free on the web. They can provide you some exercises in order to improve your typing skill or typing speed, whatever. So let's take the first test. No, because I'm using Chrome. Of course, it doesn't work on Chrome. Let's use it. Okay. Right, so I'm asked to retype the highlighted keys sequence. So let's type these keys. And okay, code execution. Let's stop this because this is actually malware. Okay. What happened? Let's see what happened. Let's close this and let's pop up our virtual keyboard. I want to show you the actual keys I'm typing. Okay. Let's start. You see, look at the Chrome color. Foreground window, background window. The background window has on focus. So if I press Tab, you see it moved on the Run button. If I press Run now, code execution. This is basically how it works. So, okay, back to the presentation. Some of you may say, okay, but it's not so easy to trick your victim into typing some strange keys like the Tab key. Is not very popular, okay? But we can do better. On Windows 7, if you open the pop-under window using this meta tag, basically you are asking your browser to render the web page using emulating Internet Explorer 7. This will bring the focus not only on the pop-under window, but directly on the notification bar. This means that you don't need the Tab key to switch on the Run button. And this means that you can get code execution by just typing one key. And this is the R key, but it changes according to the operative language, to the OS language. Let's see a demo also of this. I changed the proof of concept. There are a lot of streaming forums that require your subscription, at least in Italy. So I want to join this forum, and I want to start a registration. So I'm asked to type the CAPTCHA in order to verify that I'm not a bot. Just pressing one key, the ID key. Okay? Come on, okay. Code execution. Show again what happened, but I think you already get the message. Basically, okay, the focus is on the pop-under window. I just press the E, and code execution starts. Okay. Let's close this, and let's go back to our presentation. Second attack. The second attack is works on Internet Explorer and Chrome on Windows 8. The user scenario starts with a similar approach. So you visit the attacker website. The attacker website spawns the pop-under. The pop-under goes on the background. It starts to download the file. In the meantime, the attacker tricks you to click on a given link or button that is present on the foreground window. The foreground page is listening on mouse movements, okay, using JavaScript. And as soon as the mouse is hovering on the button, the foreground window is closed. And if timing is appropriate, there are good chances that the click is taken from the underlying windows, okay? Attack scenarios like this have been already discussed by other security researchers, for instance Michael Zaleski or Colin Jackson. Colin Jackson actually tested this approach for clickjacking over a sample of 2,000 persons using the Amazon Mechanical Turks. And he found out that the success rate of this attack, at least for clickjacking, is more than 90%. So it's quite dangerous. So why are we talking again, even if it's not a brand new attack? Because the effectiveness and the danger presented by this attack is by far more on Windows 8 than on Windows 7. Why? Because every time a file is downloaded from the web, the operating system writes a file to the file system that is called a zone information file. This file is an alternate data stream that carries information of the zone, the security zone you downloaded the file from. So it can be internet zone, local machine, whatever. What happened in Windows 7? In Windows 7, when you launch an unsigned executable downloaded with your browser, this prompt, this confirmation dialog will pop up. And this is not bypassable. Okay? This mechanism has been dismissed in Windows 8. And a smart screen check is performed instead. And I will show you later how to bypass smart screen, okay? So this means that on Windows 8, this turns into launching an executable, so executing code with just one click. Let's see this in action. Let's move to Windows 8 again, pop up Chrome. Okay. So let's click to view one of my photos. Okay, this is one of the pictures with me and my friends go on holidays in Sicily 2 or 3 years ago. I want to comment this photo and see that I like this photo. So move on the like button and the foreground window disappear and the background window is available. Okay, we have no connection now, but it should work. Let's try again. It should work quite good if you have internet connection. Let's try again. Fine. Code execution. So if timing is appropriate, there are very, very good chances to trick the user into click and then switch the windows. Of course, attack like this can be used in similar scenarios. For instance, for abusing HTML5 privileges. The proof of concept is already the same. You see, I'm listening to the mouse movements, and as soon the mouse goes over the like button, you see, the foreground window is closed, the background window is turned on. And then if I'm not careful, I'm granting this website the privilege to know my position. Let's see if it works. we should be, okay, right. The last example for this attack is clickjacking approach. I mean, you can use this attack in order to perform clickjacking also for websites that implement some anti-framing technologies. For instance, Twitter, Google, Facebook, I don't know any others. So more or less is the same. So I open a background Windows, as Maria noticed. So let's wait a few minutes. Twitter is loading on the background, and it should be loaded now. And if I go and you see, there is basically a proof of concept for allowing clickjacking. Why it works? Because actually Twitter is in a completely different Windows. It's not a frame. And so the anti-framing protections cannot be applied here. So let's go back to the presentation. Okay, defeating HTML5 privileges, we have seen. Anti-clickjacking, we have seen. Okay, are there any limitations for the couple of attacks I've showed you? Yes, there are a couple of limitations. The first is smart screen filter. The second is user access control. What is smart screen filter? Smart screen filter is one of the technologies that browser vendors have implemented in order to block access to malicious files and URLs before loading the actual content. From a functional point of view, there are client-server technologies. So on the server side, there is a cloud reputation-based system that scans the web for finding malware samples and phishing sites. It categorizes them, assigning each of them a score, a reputation. And on the client side, there is a browser agent that anytime you download a file and try to execute a file on your browser, it asks the cloud-based system, is this file safe? And it receives information from the cloud and performs warning or blocking functions on the client side, depending on the results. There are basically two implementations. The first is safe browsing. Was developed by Google, but it is used also on Safari and on Firefox. It's based on Google Safe Browsing API version 2, supports URL reputation and application reputation only for Chrome. On the other side, there is Smart Screen Filter. It works more or less in the same way, but it is a Microsoft proprietary technology. It was introduced in Internet Explorer 8, and starting with Internet Explorer 9 also supports application reputation. With the introduction of Windows 8, Smart Screen has been extended system-wide. This means that a Smart Screen check will be performed not only when you download the file from the web, but whenever you launch a file on your PC for the first time. Independently from whatever you loaded the file, okay? From USB key, from a CD-ROM, from the web, whatever. A Smart Screen check will be performed. According to these reports, these charts provided by NSS Labs, the effectiveness of these solutions, of these technologies, are quite good. For instance, Internet Explorer 10 is able to catch almost 100% of malware samples using Smart Screen. You can see that those technologies need a few days for catching new malware samples because they need to connect enough feedback, collect enough feedbacks from malware intelligence providers and so on. From a technical point of view, how Smart Screen works. Every time you download a file, you provide to the server side those informations. Your IP, the URL you downloaded the file from, the file hash, the file name encoded in base64, and the signing certificate, if available. All of these encoded in an XML format. And what is the response? The response is basically a notification bar, ranging from a successful notification bar, okay, the application you have downloaded is okay, you can run without any problem. Blacklist, this means you have downloaded a file and a malware, okay, I want to block you. And then a reputation failure. This means I'm not sure if the application you're trying to download to open is a malware or not. But being in doubt, I will disable the run button. If you want to actually run it, you have to first go on action and then go on run. Okay, but Smart screen filter can be abused in a number of ways. There are a number of workarounds. Okay. First of all, reputation check used by Smart Screen is not 100% safe, 100% reliable. I found a website. It's called minotauranalysis.com. On this website, there is a huge list of X-tweet. An X-tweet is basically a shortened URL linking to some malware that is spread all over Twitter. So they are quite popular URLs. And I found that more than 20% of the samples provided on this website will go through Smart Screen. Even if these are actually malware, they are considered malware by VirusTotal, for instance. Then, response time for catching new executable samples allows for easy bypass in the first publishing days. As I showed you before, this system needs to collect enough information to actually recognize new malware samples and to say, okay, this is malware, this is not. So in the first publishing days, if you publish a malware, you have the greatest chance of bypass. The third way to work around the Smart Screen deals with application signing. Basically, when dealing with signed application, Smart Screen will only look at the certificate reputation and not to the application instance. So basically, if you are able to steal a trusted certificate, for instance, remember what happened with DigiNotar in SSL steal episode, you can sign your malware with those certificates, distribute it. The Smart Screen will only look at the certificate reputation. It will go completely through any check. But if you are not lucky and you cannot steal a trusted certificate, you can buy a brand new extended validation certificate. These are brand new certificates provided by Symantec and DigiCert, if I remember well. They will cost a lot more than a standard code signing certificate, but they will provide you an immediate good reputation, even if no prior reputation linked to those certificates exists. So you can spend 1,000 euro, buy a certificate like this. For sure, the providers of the certificate will ask you some questions in order to identify you clearly. But I'm sure that these are the types of things that cyber criminals can deal with. And okay, you can buy a certificate, sign your malware, and distribute it using the attack you saw before. So the one-click attack or the one-key attack. The last way to bypass Smart Screen is, of course, controlling the internet connection. Being a client-server technology, if you control the connection, you control the result. So, in a man-in-the-middle scenario, you can trick your victim to connect to an access point controlled by yourself and use the attacks that I've demoed before in order to download some file. At a given point, the victim machine will try to connect to Smart Screen, in order to check the identity of the downloaded malware. But the connection is dropped by the attacker, okay? And what is the result? The result is a new notification bar complaining about the fact that it's not able to connect to Smart Screen, but still enabling you to click on the run button. So, if you can trick your victim to type the R key once again, you can get execution, and in this case, it's not standard code execution, but arbitrary code execution, because we have bypassed the Smart Screen. Let's see this in action. Internet Explorer 10 on Windows 8. The proof of concept is the same. Let's drop my connection. Sorry. Okay. Let's retype the allied key sequence. Nothing happened. Let's try again. Oh yes, it was starting. because I'm connecting to some other, okay. It's a backup connection, okay. Let's try it again. Okay, right. Now I'm not connected. Okay, let's type our sequence. Ergo tab RX. Okay. Arbitrary code execution. Let's see. Let's close this. The explanation is quite straightforward if you understood the previous attack. Basically, you start to type a captcha or a combination of keys like this: R tab R. When the first R is typed, you start to run this application, the load application. Then, after the check is performed, the smart screen agent complains about the fact it's not able to connect to the smart screen server. Then press the tab to move the focus on this button, and then type R once again to run the code. This works on Windows 7, Internet Explorer 9, and 10. The second limitation is the user access control. There is no solution about this. Okay. This is triggered when it was introduced, if I remember well, in Windows Vista. It is triggered when administrative privileges are required. Okay, you can't bypass that. But the question is, do you really need administrative privileges in order to cause serious damage to your victim? Of course, the answer is no, because malware samples like this can do a lot of bad things. For instance, key logging, content injection, auto starts when the user log on, without administrative privileges. So, at the end of the day, smart screens filter, okay, yes, we can work around this. User access control, no, we can't work around this, but we are happy the same because we can do a lot of bad things. So, let's sum up. Code execution, we can do this with one key or one click on Internet Explorer. In man in the middle, also arbitrary code execution. We can do with one click on Chrome. Plugin ActiveX and HTML5 API activation we can do using one key or one click on Internet Explorer, using only one click on Firefox and on Chrome. Some proposal in order to solve these problems. First of all, notification on background window. They are useless. At best, they are useless. In reality, they are really dangerous. So, why don't show the notification after some seconds since the navigation window regained the focus? This approach has been already taken from Firefox. For instance, when you install a plugin, there is a counter on your button, 3, 2, 1, and then the focus is put on your button and let you install the plugin. This is more safe technology. Second, disable the tab key notification bar. Just use a mouse. If you are concerned about accessibility problem, you can enable more complex keyboard sequence in order to limit the chance of being social engineered. Third, some sensitive notifications, for instance, file downloading notification, should be kept in a static frame of the Chrome and not depending to the navigation window. And fourth, browser-initiated switches between windows belonging to different domain should be always being combined with some graphical effects, for instance, fading, a lightbox, things like this. Just think what happened with the Twitter proof of concept. That was not a user-required switch, but it was a browser-initiated switch. And I need some instrument, some mechanism to provide me a notification about the fact that two different navigation windows belonging to different domain has happened. So, at the end of the day, let's jump to conclusions. Browser shift from model to model certification is still not mature, and some critical issues still exist in implementations. I've showed you a couple of techniques that allow for still to remote code execution with minimum user interaction, one click or one key. And just a final note, the easy way is by far the most exploited in the wild. So, okay, we should care about 0 days, memory protection, and so on. but we should care about also about more simple exploit techniques that are really easy to be reproduced in the wild and can be used on a mass scale to cause a lot of damage. Okay, it's enough. I've ended. Thank you for your attention, and if you have any questions. No, just on Windows. Just on Windows. Windows 7 and Windows 8. Yes, I tested on Ubuntu with the one-click attack for Chrome, and it works. I don't remember the exact version. I think of Ubuntu 12.4.04. Yes?
I don't want to initiate it fully works, but by your opinion, after all that research that you've done, what is the best and most secure browser nowadays?
Okay, let's pull off this speaker tag. Okay, I use Chrome. Okay, I use Chrome because standing to the most recent reports, it's the more protected against memory corruption exploits that are the most dangerous. Let's talk clearly. But for this kind of attacks, Chrome proved to be not safe enough. Okay, because I can assure you, if you try the attack on the wild, you can test it on my website. I will provide, if you're interested, the live URL of this attack. You can test. It's a seamless experience. Go, click, and you are done. Okay. Dealing with user interfaces, I should say that the safer is Safari, because keep staying on modal notifications only, so you cannot bypass this.
So there's no safe way to browse the web nowadays.
Let's say there's no at this moment there are no browser that safely allow you to protect yourself against these tricks.
Don't you think that pop-ups are evil and
Sorry?
Don't you think that pop-ups are evil and interest at all? That we should be able
No. I asked this question also to myself while preparing the slides. You have always to balance between, let's call it business needs and security needs. Pop-ups are widely used in the web, and if you at once dismiss the pop-up, a huge mess will be caused. A lot of legacy web application will not work anymore. And so you can't stop the problem by just blocking pop-up. You can fight pop-under instead. Pop-under are really evil because there is no justification for popping up a window and then putting it on the background, even if the switch is, especially if the switch is very, very fast. And as I said before, especially Chrome is chasing acres that works for enabling pop-under. When I first wrote the pop-up concept, I wrote it on Chrome 24. Now we are on Chrome 26, and I had to patch the proof of concept 2 times because they closed the API, they dismissed the API that I was using in order to control pop-under. So it's an evolving chase. Because as far as I know, you can keylog, you can sniff the keystrokes typed by user without any privilege, administrative privilege. You can do in user land. Sorry? Without the driver, yes. It's a user land API. Inside the browser, for sure. Out of browser, I don't know. I don't really know. It's good enough for this. Yes.
Tell me, is it possible to develop some type of plugin or such, maybe the same thing, such as add block, in order to maybe provide user more full information about
Okay. The quick answer, yes, I think it should be possible. Longest answer. This proof of concept has been built in a standard configuration. So using the pop-up blocker, smart screen activated, of course, and what do you call a plugin for ad blocking and so on? In the latest year, have been implemented as a core functionality in browser. So basically, already in Internet Explorer and Chrome, there are ad blocking functions, but you can bypass the same.
Why not to disable completely the execute button from the browser?
Why completely disable?
The execution button from the browser. I mean, if you download the exe file and then you still able to execute the exe file, you can disable.
User yes, it's
to the browser to execute, but then by something
it actually was the approach used by previous browser version. You download the file, then you have to go to a different section of the browser, of the Chrome, download list, and click. It's a notification bar provide you a smarter way to interact with the file you have downloaded. Also, in this case, I think there is a struggle between security guys and user interaction guys. Okay, it's smarter for business guys to provide a one-click opening of downloaded file. Maybe they basically didn't talk with security guys when designing this kind of interface. For instance, Internet Explorer 8 is by far more safer than Internet Explorer 9 when dealing with this kind of notification bars. Some more questions? Okay, thank you. Thank you.